Okay, so this is similar to the rhino problem, except that this is inelastic, which means we're not going to have conservation of kinetic energy. But we will start with a conservation of momentum. This is, again, mostly difficult because of the algebra. So we have the mass times velocity of the bullet plus the mass of the block times 0, which is 0. It has no momentum initially, equals, when the bullet comes out the other side, it's moving slightly slower, so m times 0.466v plus big M times big V, and these are the things we're trying to solve for. I can do a little bit of algebra, combine like terms, and I end up with an equation that has too many variables to deal with. For the second part of the problem, it talks about the kinetic energy. So initial kinetic energy is 1/2 mv squared. The block has no kinetic energy, so we don't need to write that. And then the kinetic energy after the collision is equal to 0.323 of the initial kinetic energy, which is equal to 1/2 m this v quantity squared plus 1/2 big M big V squared. Which, if I make a substitution in here for k initial, I can then, multiply this out, combine like terms, and I get another simultaneous equation. Once you have the equation in the two red boxes, really you're done with the physics, and then it becomes the algebra. And it's kind of up to you how you'd like to solve for this. You can solve for big M. I would probably solve up here. And by the way, that's a little v. Sorry, I wish they had used different variables. That's a m times little v. You solve for either m or v here, plug in, and go through and solve. Try that. When I went through all my work, I ended up with big V is 0.861 times little v meters per second, and big M is 0.62, the little mass in kilograms, or whatever the unit for mass is on this problem.